welcome. We're looking at the second order differential equation. Second order differential equation. I want to, and we have these few of these questions. We still have more to explain these theorem. We have this second differential minus 2y prime plus y equal to 0. We have the second one also, y double prime minus 5y prime plus 6y equal to 0. But before we start solving questions, I want to lay the foundations to how to solve second order differential equation. Okay, recall that second linear ODE, ordinary differential equation, is of the form y double prime plus p of x times y prime plus q of x times y equal to g of x. That's the format for second order ordinary differential equation, second linear ordinary differential equation. Okay, then point number one to note is that if g of x is 0, okay, then the equation becomes what? It becomes homogeneous. The equation becomes homogeneous. Okay, and if the g of x is not equal to 0, we call this equation non-homogeneous. Non-homogeneous. Okay, second linear ordinary differential equation. So that starts on these aspects. Let's look at examples to explain homogeneous differential equation. Let's see this first one. If you have example, you have y double prime plus, let's say 4x squared. Okay, following that format. Okay, y prime, then plus your q of x. Let's imagine we have 4x. Okay, don't forget the y attached to it, equal to sine x. The g of x must be function of x. So this case now, this is what? This one is what? Second linear ordinary differential equation, and is what? And it's non-homogeneous. This is non-homogeneous. Okay, this is non-homogeneous. This is non-homogeneous. Let's see another example. Imagine you have another one again. You have, following these formats, y double prime plus 4x squared, y prime plus maybe 3x. That's your q of x times y. And possibly you have cos x y prime. Okay, so y prime is there, y prime is there. We can bring them together. So move this one to this side. So we have y double prime plus this will be equal to y prime into brackets 4x squared minus cos x. Okay, plus what? Plus 3xy equal to 0. So this one will become second linear ordinary differential equation, and is what? And this case is what? Is homogeneous. This is homogeneous because your g of x is equal to 0. Okay, so that's that on these aspects. I want to say welcome. As you are coming in, begin to give the video a thumbs up. Begin to give the video a thumbs up. Prime plus b y prime plus c y equal to 0. Okay, so this equation is called second order ordinary differential equation. This is called second order with constant coefficients, with constant coefficients, with constant coefficients. And those coefficients are, the constant coefficients are A, B, and C. Okay? So the goal, our target is to solve this equation. I'll call it equation 1. To solve this equation. That's our target. Is to give a suggestion. Let's have a suggestion that let y be equal to this as a solution of what? Of equation 1. Okay, so this is what is the solution. Is a solution of equation 1. Then we're going to get the first differential of this solution of equation 1. Okay, which will be equal to what? This one. This one. Then the second differential will be equal to what? R squared. This. Okay. Actually, I did something like this in the afternoon, but I'm doing the updates. Okay, of that version. This is the updated version. Okay. So that's that, but it's going to be longer than that one. Okay. So then begin to put in this one into this equation 1, and that will give us the y double prime is what? Is r squared times this one plus b. The first differential is this, and then plus c. The c times y. My y is what? Is this, equal to what? Equal to 0. Then this one is here. E to power rs is here. It's also here. It's also here. So you can factorize that. If you factorize that, you're going to have ar squared plus br, and then plus c equal to what? Equal to 0. Then divide this equation by e to power rx. So if you do that, we're going to have this plus br plus c equal to 0. And this is called auxiliary equation. This is called auxiliary equation. This is called auxiliary equation. Okay, this is called auxiliary equation. And if you check this auxiliary equation, which is the solution of equation 1, is quadratic in nature. It's quadratic. This is quadratic, and we can solve this either by factorization or using what? Using quadratic formula. The auxiliary equation will be equal to, if you use your quadratic formula. So this is quadratic equation. So we're going to have r1 equal to minus b plus square root of what? B squared minus 4ac over what? Over 2a. Then the second one will be what? R2 equal to what? Minus b. B squared minus 4ac over 2a. Okay, so these are the roots of the what? Auxiliary equation. Okay. Then we're going to make a conclusion on these roots. Okay, on the nature of these roots. And we're going to use discriminants to make 3 cases. Okay. Okay, to determine the nature of these roots using discriminants. And then case 1 is if your discriminants, which is b squared minus 4ac, if your discriminant is greater than 0, then the roots of the auxiliary equation we have 2 distinct real roots. 2 distinct real roots. 2 distinct real roots. So that's the 2 distinct we have 2 distinct real roots. So that means your R1, R2, they're not equal to each other. For example, if this is a 2, this can be minus 3. If this is a negative, this can be plus. They are not equal to each other. Okay, so in that case now we're going to have two solutions of the auxiliary equation, y1 and what and y2, and that will be equal to what? E to power what? Based on our suggestion, e to power rs, and that will be what? Minus 2. Sorry, that will be r1. The second one will be equal to what? E r2 times x. So the general solution will be equal to c1 times y1, which is this one, plus c2 times e r2 power r2x. Okay, so that's the general solution of the homogeneous differential equation. So that's the general solution. Okay, that's the case one. That's case one. Case two is when your discriminant is equal to 0. When your discriminant is equal to 0, then the root of the auxiliary equation, we have one equal root of that equation, or the solution of the auxiliary equation, we have what? One equal root. So then this two solution, y1, y2, will be equal to what? Will be equal to e to power what? Rx. The second one will be equal to what? X e to power rs. So the general solution will be equal to the general solution will be equal to y equal to c1 y1 plus c2 x this. So that's the general solution. And the third case, if discriminant, okay, less 0, if discriminant less 0, we're going to have two distinct complex roots, okay, which is what? Which is r1 will be equal to alpha plus beta I, r2 will be equal to alpha plus what? This will be minus beta I. So that's that. So what we mean by that is that the solution of your auxiliary equation will have a complex equation, okay, whereby you're going to have the real part. The real part is the alpha. That's the alpha. The imaginary part is the what? The imaginary part is the beta. So the two solutions now, y1, y2 will now become, y1 will be e to power alpha x cos beta, then y2 will be equal to what? Alpha e to power alpha x sine beta x. That's the two solutions. Okay, then the general solution will be equal to what? C1 times y1 cos beta x plus c2 alpha e to power alpha times x sine beta x. The beta is the coefficient of the I. Okay, actually the solution is going to be alpha plus or minus beta I. That's like solution of that auxiliary equation when discriminant is negative. Okay, so that's that on the three cases that we can have when you solve your auxiliary equation. Plus y equal to 0. We're told to find the general solution. find the general solution. That's what we are told to do. Find the general solution. Find the general solution. So if you look at this now, don't forget our auxiliary equation, okay, is of this form, plus what? BR plus what? Plus C equal to what? Equal to 0. Okay, so that's the auxiliary equation. Now correspond this to the given problem. The attachment to your second differential is 1. So A is what? A is 1. The attachment to this is fourth differential. Okay, the attachment to first differential is minus 2. That's your B, minus 2. So minus 2, that's your B. Then the Y, the attachment to your Y is what? Is the C. That is what? Plus 1. So that's the auxiliary equation. That's the auxiliary equation. That's the auxiliary equation. Okay. Or you can make it this way. Your second differential, your first differential will be R. Okay. The first differential will be what? The first differential, Y prime, will be R. The second differential, Y double prime, will be R squared. Your third differential will be what? R cube, and so on and so forth. So if that's way you like, then that means R plus times minus 2. Yeah, that's the second differential. That's R squared. The one that has no differential, so just write the coefficient of that place, which is plus 1. But the best way is to use this one, the auxiliary equation, and begin to correspond it together. Okay, and form your auxiliary equation. Okay, so what we can do now, we can use the formula method or factorization method to solve this equation. Okay, this one times this one, that's a plus R squared. Factors of 1, I can generate minus 2. That'll be what? Minus R, minus R, minus 1, minus 1. If you multiply these two together, it's going to give you R squared. Okay, then now come here, replace this place with these two factors. So we have R squared minus R minus R plus 1 equal to 0. And then begin to pair it. This one and this one, R is common. Okay, so we have R minus 1. This one and this one, minus 1 is common. Take it out. We have R minus 1 equal to 0. Okay, so if you solve it, that will be equal to what? We're going to have R minus 1 into bracket R minus 1 equal to 0. So that's what we have there. R minus 1. So, and this implies this is equal to 0. R minus 1 is equal to 0. R minus 1 is equal to 0. So in that case now, R is equal to what? R is equal to 1. This is what? This is twice. This is repeated roots. This is repeated what? Repeated roots. So in that case now, when you have repeated roots, it means your y1 is equal to what? E Rs. Your R is 1, so you have this. The second solution will be equal to what? X. X. Okay, so the final conclusion, the general solution will be equal to what? C1 times what? Times y1 plus C2 times what? Y2, which is this. And that's the general solution for that second ordinary differential, second order with homogeneous differential equation. So let's see the second question. The second question, we have y double prime minus 5y plus 6y equal to what? Equal to 0. So what you're going to do is what? Write the what? The auxiliary equation. Write the auxiliary equation. Write the auxiliary equation, which is what? Which is this. Which is this. Okay, so correspond this to your question. The attachment to your second differential is 1, so A is 1. Attachment to your first differential is what? It's minus 5, so B is what? Minus 5 R. Okay, the attachment to your y is 6, which is what? Which is the cosine, which is the c. So that's what? Plus 6 equal to 0. Okay, then multiply this one and this one together. That's a plus 6r squared. Two factors of this can give us minus 5, either by adding or subtracting. That's a 2 and 3. Minus this, minus this. So you can pair this one, the r squared, one here, one here. So come back here and replace with the 2 factor. So we have r squared minus 2r minus 3r plus 6 equal to 0. So pair this one, that'll be r is common. Here also, minus 3 is common. Okay. So when you factorize, these two must be the same. Pick one of that, then r minus 3 equal to 0. So this is equal to 0, that's r minus 2. This is also equal to 0, r minus 3. So r1 is 2, and then r2 is 3. The two solutions for the differential equation, y1 will be equal to what? E, don't forget this rx. For my r1 is what? Is 2. That'll be 2, and then y2 will be equal to what? E3x. So the general solution will be equal to what? C1 times y1 plus C2 times what? Y2 plus 3y double prime plus 3y prime plus y equal to 0. So that's what we have there. Okay. So the auxiliary equation, solution, the auxiliary equation, is going to be what? The third differential will be equal to what? R cube plus 3, the prime, double prime as second differential, that will be 3r squared plus 3r plus 1 equal to what? 0. I've said that your first differential is r, the second differential is r squared, the third differential is r cube, and so on and so forth. Okay, but if you look at this now, this is polynomial. You cannot factorize it. You can't factorize it. You're going to use a factor theorem. Okay, factor theorem with polynomial division to solve this. So what we are going to do, this is a function of r. Okay, let's make it is a function of r. Okay, it's a function of r. And factor theorem says that if r minus 1, is a factor, okay, if r minus 1 is a factor of this, then if you equate this one to 0, then you're going to have f of what? If you equate this one to 0, r will be equal to 1. So anywhere you see r, you put 1 there. F of 1 will be equal to 0. If you put 1 in this equation, can it give you 1? No. So that means r minus 1 is not equal to what? Is not equal to 0. You can try it. This is what? This is 1 cube, 3 times 1 squared plus 3 plus 3 plus 1. So this is not equal to what? It's not equal to 0. So that shows that r minus 1 is not a factor. It's not a factor. R minus 1 is not a factor. Okay, can we check r plus 1? If r plus 1 is a factor, then f of minus 1 will be equal to 0. Let's confirm that. So if it is equal to 0, then r plus 1 is a factor. Let's do that. Put it here. That'll be minus 1 cube and then plus 3 times r squared, that's 1, that's a minus 1 squared, and then plus 3 times minus 1, okay, and then plus 1 equal to 0. So let's check that. Let's check that. The first one, minus 1 cube, will give us what? Give us a minus 1. This one, minus 1 square, that's a 1 times 3, that's a plus 3. Okay, and then this one, 3 times minus 1, that's a minus 3. And then plus what? Plus 1. So this and this cancel is equal to 0. That's to confirm that r plus 1 is a factor. That confirms r plus 1 is a factor. It's a factor. Okay, so it is a factor now. Then we now use polynomial long division, okay, to get the other factors. Polynomial long division, I've already confirmed that r plus 1 is a factor. Okay, we use it to divide the auxiliary equation, which is r cubed plus the 3 r squared plus the 3r plus 1. So what you do is very simple. You take the first one, r cubed, use it to divide the first one here, making what? R squared. So we put it here. Then use it to multiply this one. R squared times r squared times 1, that's a plus 1. Then do your subtraction. This one minus this one, cancel. This one minus this one, that's a 2r squared. Then bring the next one down. So that's what? That's a plus 3r. Repeat the process again. Take this one, okay, 2r squared. Use it to divide the first one here over r. So that's what? That's a plus 2r. So 2r times r, that's a 2r squared. 2r times 1, that's what? Plus 2r. Okay? So do your subtraction for that place. If you do your subtraction, we're going to have r, and bring this one here, bring it down. So that's a plus 1. Then take this one here, the first one here, over the first one here, r over r. That's 1, so that's plus 1. 1 times r, 1 times 1, do your subtraction. So it's confirmed that r plus 1 is a factor. Because once it's a factor, your remainder must be 0. Okay, that's what we call it remainder theorem. Remainder theorem or factors theorem. So that's what we have there. Then what this means is that your f of r is equal to r plus 1 times what? This one times this one will give you your original function. Give you your original function. Okay, and that's equal to what? That's equal to 0. Okay, so if you do this one, this is what? R plus 1. This one, if you do the expansion, this will also be r plus 1 equal to what? Equal to 0. Let me quickly show you that r squared plus 2r plus 1. Let's do that. Factors of 1 is 1 and 1. So this will be r squared plus r plus 1. And pair this one, r is common. Here 1 is common, plus 1 and plus 1. So that's that on that case. So this means r1 is equal to minus 1, r2 is equal to what? Minus 1, r3 is equal to what? Minus 1. Go to x times e to power minus x, and then y3 will be equal to s squared over what? E to power minus x. So the general solution will be equal to what? C1 times y1 plus c2 times y2, and then plus c3 times what? Times y3. So that's the general solution for that case. Okay, that's the general solution for that case. So welcome on board. Welcome. If you are new on the channel, please subscribe to the channel and give the video a thumbs up. give the video a thumbs up. You're welcome to the channel. Welcome, 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 welcome. Okay, welcome to the channel. Welcome to the channel. For the returning viewer, I want to say kudos. Thank you for coming on board. Begin to share the links of this video across your social media platform. We have fourth differential minus y equal to 0. So that's what we have. We are told to find the what? Find the general solution. Find the general solution. Auxiliary equation. The auxiliary equation will be equal to the fourth differential will be r to the power 4 minus 1 equal to what? Equal to 0. Okay? Then we can write this one as r squared minus 1 squared. So making difference of square. Difference of square, that will be r squared minus 1, do bracket r squared plus 1 equal to 0. Okay? So this one is equal to r squared minus 1 is equal to 0, which is what? R squared is equal to 1. So r is equal to what? Plus or minus what? 1. The other one, which is r squared plus 1 equal to 0, we're going to have r squared equal to what? Minus 1. Okay, then r will be equal to what? Plus or minus I. Plus or minus I. So let's get the solution. R equal to plus or minus 1. We're going to have y1 equal to e to the power what? E to the power x. Okay, don't forget that this one is r is equal to 1. I'll call it r1. Then r2 is equal to what? Minus 1. Plus 1 or minus 1. That's the case of this one. So y2 is equal to what? E minus x. Okay, then let's now go to the other one. This one, r equal to plus or minus I. So which means y3 is equal to what? We don't have the, we can write this one, the equation for the complex number. It has no real part. The real part is 0, okay, plus or minus I. So we can write it in this form, okay, which means alpha is what? Alpha is 0, okay, and beta is the attachment to your I, which is 1. So y3 will be equal to what? E alpha is 0, 0 times x, and then cos beta x. Beta is 1 times 1 times x. Okay, and y4 will be equal to what? Same thing also. 0 times this and then sine x. So this one is cos x. This one is what? Sine x. Because anything to the power 0, 0 times x is 0. Okay, plus c2 y2 plus c3 y3, that's the cos x, plus c4 y4. So that's the general solution for the differential equation. Okay. Okay, so that's that on these aspects. The thing is just for you to play with as many questions as possible. As I always say, that you need to practice. The more you practice, the better you become. Okay, so we're going to the last question for q times y double prime plus y prime plus 2y equal to 0. So find the general solution. Find the general solution. Find the general solution. Okay, so welcome. Okay, welcome to this live section. Welcome. Okay, thanks for coming on board. Begin to share the links of this video across your social media platform. Welcome. Okay, so for this part, the auxiliary equation, 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 the auxiliary equ That's the solution. The auxiliary equation is the third differential will be r cubed plus 2 times the second differential will be r squared. The first differential will be what? R, and then this one will be what? 2. There's no differential there. Just write the attachment to your differential to your y. So that's what we have there. Then we can pair this one. We can pair this one. So here r squared is common. We have r plus 2. Here we have 1 is common. That's r plus 2 equal to 0. So this one, take one of that. Then we have this equal to 0. So r plus 2 is equal to 0. So r is equal to minus 2. Here, r squared minus 1. R squared equal to minus 1. So r is equal to what? Plus or minus I. So let's get the y. The y1 will be equal to what? E minus 2x. This one will be equal to what? Y2 will be equal to. This one is going to generate two solutions. So we're going to have the real part is 0. This is changing as what? 0 plus beta I. So this one is alpha, and then this is your beta, which is 1, which is 1. So we're going to have cos x here. Don't want to waste time. Y3 is equal to what? Sine what? Sine x. Okay, because the equation is what? E to power alpha x cos x, e to power alpha x sine x. So if you do that, you're going to have this is y equal to c1 times y1 plus c2 times y2 plus c3 times what? Y3. So, and that's that on these segments. That's where we're going to drop the curtain of this live section. Okay. So at this point, I want to say thank you for staying by. Thank you for always coming on board. Anytime I'm having live section, thank you for supporting this channel. What you can do for me is to begin to share the links of this video across the social media platform. Okay.